Is Mrs. Quinn, or the virtual teaching assistant. This is my next video clip. It's slightly older age group that we're moving now. Mass and volume, weights and measures. Again, I've tried to do it from different levels as well, so it's equally good for people who have no knowledge of weights and measures, but obviously it can be built onto those who already do have knowledge. It's just hopefully trying to help people understand it a bit better. Okay, so what is mass and weight? All right, mass is used to define the density of something. All right, weight's different to mass in that it can change dependent upon the force. Still very confusing, so to put it in normal terms, if I took an orange and I put it on a set of scales on Earth where there's gravity, gravity would be the force that gave it weight, which pushes it down onto those scales. If I put the same orange on the same scales in space, where there was no gravity at all, it would measure as no weight. However, the mass of that orange would not change. It would be the same with or without any force. All right. It'd also be the same if you were trying to weigh it underwater. You know, when you get in water and you feel like you feel lighter. Again, weights of things change, but the mass never does. All right, that's the difference. What units of measurement do we use for weight and mass? Okay, there are lots and lots of different measurements and units of measurements, such as pounds, ounces, stones, milligrams, things like that. But what we're going to focus on in this stage of learning is kilograms and grams. Okay, now one of the easiest ways to remember this is the word kilo means 1,000. Okay, so how many grams do you think there will be in 1 kilogram? That's right, it's 1,000. So the word kilogram itself translates to 1,000 grams. Okay, now I'm going to draw you a quick chart here just to show you. It's just to show you a kilogram and show you the equivalence of the grams to the kilogram. Okay, so as you can see, I've got 0 here and I've got 1 kilogram here. Now in the middle, we know half of 1,000 is 500, so it's 500 grams. Now you'll see I've put 0.5 kilograms. Now those who are familiar with decimals, this will be no surprise to you. If you've not seen them before, the reason I've put a point there is because it isn't a whole kilogram yet. It's only half of one, okay? So it isn't a whole one. So you can see that 100 grams is 0.1 kilograms, 0.2 kilograms for 200 grams, and so on all the way through, okay? This isn't anything you need to memorize, that is just for your information, okay? And just to help add a bit more depth. Okay, so let's have a go here. These scales that you might see in your kitchen. How much does the flour weigh? Now the first thing you want to check is make sure what it's measured in, because this is that trips people up quite a lot. So this one I can see is the G sign, which is grams. Okay, now it's not pointing to a number, but I can see it's pointing directly halfway between 700 and 800 grams. So what do you think would be directly halfway between 700 and 800 grams? That's right, 750 grams. Next, how much do you think the apple might weigh? Now this one, you'd use it to count these little tiny lines here, can you see? And you'd see how much it goes up in, okay? So, it goes up to 70 grams, and then I've got 72 grams. Okay, how much does the sweet weigh? And again, I can see we're measuring in grams. It's between 0 and 10. Now, what's between 0 and 10? Exactly halfway between 0 and 10. I know that's 5 grams. Okay, and last but not least, this one here is measuring in kilograms. So I need to keep an eye on that so I know what I'm measuring in. How much would the carrots weigh? That's right, 1 kilogram. So if you've got some scales at home, get some different items, have a weigh of them, and see what they weigh, and just try and weigh different things and keep a record of it just to get some practice. Okay, I'm not going to labour the point on here, it's just a quick tutorial for you. Okay, now Sometimes you'll get a question that gives you only half the information. How do you think you'll calculate the weight of these balls over here? Okay, now the scales are balanced, which means this over here weighs exactly the same as these over here. So this weight is the same as these two together. Okay, it means they're equal. Now, one side is a 6 kilogram weight and the other has 2 red balls. So to find the weight of each ball, we need to take the total weight, which we know is going to be 6 kilograms, and divide it by 2, as there's 2 balls. So 6 kilograms divided by 2 is 3. Yeah? With this one, again, we've got equal weight. So we know this weighs the same as this. So we know the balls in the square all add up to the same weight on the other side, which is a total weight of 10 kilograms, add 5 kilograms, add 100 grams. Now what I've done is I've colour-coded it here just to help. So the 10 kilograms is there, 5 kilograms is there, and I've had to do a decimal point now because remember that's only 100 grams. So it's 15.1 kilograms. Okay, now I know that in my 5 times table I'm looking at, because there's 5 balls. So let's have a look. I've got the 15 kilograms here and I'm going to divide it by 5 because that's the number of balls I've got. Okay, so it's 3 kilograms, which means that if each ball weighs 3 kilograms, the square must weigh 100 grams. Okay, so what's volume and capacity? Volume is how much space a 3-dimensional object takes up. Okay, so it needs to be an actual object, not a picture of something. Or now a good example to give you would be one of your measuring jugs in the kitchen. It's the size of your measuring jug. Okay, capacity is the maximum amount that an object can hold. So that'd be the maximum amount that your measuring jug could hold inside it. All right, how does volume vary from mass? A good example would be a massive cardboard box. Okay, it's got a really large volume, so it's a large area. It takes up quite a lot of space, but it would have a lower mass or density than a bowling ball. So a bowling ball is smaller, but we know it weighs more. Okay, we know it's got more mass and density to it. Yeah? Now, the volume of an object can change depending on the form of the object, such as gas, liquid, solid. So, like, is it steam? Is it boiling water? Is it a solid like sand or something like that? Volume can be measured in cubic centimetres, which we call centimetre cubed, with a little 3 up there. The reason there's a 3 there is because cubic centimetres means it's a number that's times by itself 3 times, okay? Or millilitres, which we see here as ml, okay? 1 millilitre is the same as 1 cubic centimetre, and 1,000 millilitres is the same as 1 litre. All right, again, go and have a look around your house at some juice bottles or, I don't know, some orange cartons and things like that, and milk bottles, and see how much is in there. You'll see quite often they're shown in litres. All right, measure and compare. We're going to look at measuring liquids today. All right, so when you look at a measuring jug that you've got at home, you'll see similar markings to these ones here. Okay, which I've got my 1,000 millilitres here, which is the same as 1 litre. And again, you can see I've done the same. Because it's only half a litre, it's 0.5, but it's 500 millilitres. Okay, let's have a practice. So here's my jug. All right, how much has this one got in, do you think? It's right in the middle of 400 and 600. How much do you think that would be? If you want to pause it to have a bit longer to look at it, do it now, because I'm going to move on. It's 500 mil. Well done. The next one. Oh, now this hasn't even registered on number yet. So I know it's just gone up to this first line here. But I know the next line is 200. And then that one there is 400. So in the middle between 200 and 400, that must be 300. So I know that these little lines are counting up in hundreds. The big lines are counting up in 200s. So if I've gone up to my first little line, how much do you think that is? brilliant. Well done. And my next one. Ooh. So again, this is between 800 ml and 1 litre. Now we know that 1 litre is 1,000 millilitres. So between 800 and 1,000 millilitres is 900 millilitres. Well done. And last but not least, there we go. How much have we got in here? 1 litre and 1,000 millilitres. They're both exactly the same. I hope this has helped clear things up for you. Please leave me any comments, any feedback, good or bad. And like I say in most of my videos, the vocabulary used is literally half the battle. So if I can help with anything, please just drop me a message and send me a request through, and I'll make you another clip. Or if I can improve on anything, let me know. All right, take care. If this has helped you, please do share it. Thank you. Bye.